Today we're talking about the Pythagorean theorem. In a right triangle, the hypotenuse is the side opposite the right angle, and the legs are the two sides that make the right angle. The Pythagorean theorem says that for any right triangle, the sum of the squares of the length of the leg equal the square of the length of the hypotenuse. So if the legs are A and B, when you add the square of each of these legs, it should equal the square of the hypotenuse. And this is how the leg and the hypotenuse of a right triangle are related by the Pythagorean theorem. If we have to find the unknown length, and we have this right triangle where we know that one leg is 10, we know the hypotenuse is 12, and we don't know the other leg. We know that the Pythagorean theorem says that one leg plus the square of one leg plus the square of the other leg is equal to the square of the hypotenuse. So that means that right here we could say 10 is equal to A, B is B, and 12 is C. So if we substitute into the equation, we could say 10 squared plus B squared has to equal 12 squared. What's 10 squared? 100 plus B squared. What's 12 squared? 144. Can we solve for B squared? We have to subtract 100 from both sides so that B can be by itself. So now we've got B squared is equal to 44. Yes or no? Okay. So how do we get B by itself if we have squared? We have B squared. We have to square root. So the square root of B squared is B, and what you do to one side you do to the other. So B is equal to the square root of 44. Now can we simplify the square root of 44? Yes, we could say square root of 4 times the square root of 11. So 4 is a perfect square. Can we simplify the square root of 11? No. So B is equal to 2 times the square root of 11. If we need to find the unknown length of this right triangle, it means we need to find A. A is one of the legs. We can use the Pythagorean theorem. So we can say A squared plus B squared equals C squared. Do we know what A is? No. We know what B is, so now we can say 20 squared, and we know what C is, 25 squared. This means A squared plus 20 squared is 400 equals 25 squared, which equals 625. Can we solve for A? We subtract 400 from both sides. A squared equals 225. How do we find A by itself? What do we have to do to get rid of the exponent 2? Square root. The square root of A squared is A. And what's the square root? So A is equal to the square root of 225. What's the square root of 225? 15. 15 times 15 is 225. So that means that this leg is equal to 15. If we need to find the unknown side, in this case it's C. It's the side opposite of the 90-degree angle, so this is the hypotenuse. We can use the Pythagorean theorem. We know that A is 10, so 10 squared plus B, that is 24, 24 squared equals C squared. What's 10 squared? 100. What's 24 squared? 576. And that's equal to C squared. So now we can add 100 plus 576, so 676 is equal to C squared. If we need to solve for C, what do we have to do? Square root. square root to both sides. What's the square root of c squared? C. And the square root of 670. So the square root of 676 is 26. That means that the hypotenuse is equal to 26. Determine whether the triangle with the given side length is a right triangle. So remember we said that the Pythagorean theorem only works with right triangles. So if the Pythagorean theorem says that a squared plus b squared equals c squared, that means that for this triangle to be a right triangle, it has to make the Pythagorean theorem true. So if we substitute here, we would say 3 squared plus 5 squared has to equal 7 squared. 3 squared is 9. 5 squared is what? 25. And 7 squared is 49. What's 9 plus 25?
34.
Is 34 equal to 49? No. Therefore, is this a right triangle? No. Let's check with another one. Let's say we're given that A equals 15, B equals 8, and C equals 17. Is this a right triangle? What do we use to check? A squared plus B squared equals C squared. So we could say 15 squared plus 8 squared equals 17 squared. 15 squared is 225 plus 64 has to equal 17 squared, 289. Is this true? Yes. 289 is equal to 289. So is this a right triangle? Yes.